whenever you want.
Right.
I guess Carlos, it's
So
up to you.
welcome. Okay, it looks cool. What? Okay, can you hear me well now?
Yes.
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 Okay. Sorry, I don't know if I'm having connection problems. I think maybe. Okay, let's try with the video. If you have problems hear me or seeing me, just wave and notice, Mohammad.
It's fine.
Okay, welcome everyone. Fine, good. Welcome everyone to the second SMAC seminar. As you may remember, these are short meetings for astrocomputing knowledge. And the idea is to get people introduced to some of the most useful tools, or what we consider some of the most useful tools for doing research and other kinds of tasks. Today we'll have a continuation of what we did in the first session that was dedicated to the POSIX systems and the Linux shell and the shell. And today we'll continue with the shell, but going a little bit higher in level, taking a look at more powerful tools. And the speakers today will be, again, two people. We'll have Mohammad Akhlaghi here on the right, and Raul Infante. And they will walk us through some of the most useful tools that we have for the shell. Please take it away.
Okay, thank you. Thank you very much, Carlos, for the great introduction, and to the IST Talks for organizing this. So before going on directly onto the command line, I'll just start with well, a short introduction to this talk. So from the IAC Talks webpage, in the abstract, in the end, you can see that there's a link to the commands that we'll be reviewing today. And when you open that link, you can see over here the list of commands, and with like it's well explained. So even if you don't have this recording later, you can still understand it, hopefully. Yeah, so this is how you can archive. So you don't have to worry about writing anything down or anything. We're going to run exactly these commands, and we're just going to talk over them, and it's recorded. So for the data set, so, because we didn't want it to be just an abstract demonstration of, some commands. There's already many examples in YouTube on how to run shell and everything. So we're actually going to use a real astronomical data set. We're going to go into the catalog of the UV-UDF survey. It's the image, so it's the catalog, so it's like the magnitudes and estimated photometric redshifts and things of one of the deepest fields with the Hubble Space Telescope. That over here you can see its webpage. So effectively, they've done a very deep survey. This is the result of many deep surveys. This is like one of the most recent, and yeah, you can see this image. So the catalog we'll be using is actually a catalog of all the sources in this image. And when we talk about colors and redshifts and things, you can actually see this whole field is actually 3 arcseconds by 3 arcseconds. So I think that's enough for physics and data. Let's get on to the commands. So Raul will start with the first set of commands, and I'll just stop share screening so Raul can continue.
Okay, thank you, Mohammad, for the introduction. Let's see if I can share my screen. Do you see it?
Yes. Very nice.
Okay, so I am Raul. I'm going to explain the first part of this set of online tools. And let's go, okay? So as Mohammad has said, let's download this catalog and let's play a bit with the command line tools. So here, the first thing that we are going to do is download the catalog with the program that you get. Okay, then we have to specify the URL. Okay, so we will paste here the URL. And then it will download the catalog, as you can see here, but it is gonna save the catalog with the default name, okay? So if we want to change the default name, we can specify with the option dash capital O a new name, for example, catalog dash raw dot fits, and it will save the catalog with the different name, okay, with the name that we have specified. Okay, now we are going to use a program from GNU Astro, which is a set of programs for manipulating the astronomical data. We will see all of this command in the next talk, but yes, here we are going to use this program to convert the catalog, which is in FITS format, to a plain text catalog. Okay? So the GNU Astro program are available into the IEC computer, and if you prefer to use into your laptop, you can of course install it. For example, if you are using Ubuntu or Debian-based operating system, you can install it as usual. No? You can do sudo apt install and then GNU Astro. Okay? It will ask you the password, and you will get install all the programs to use it. But here I have all of these programs already installed. So let's convert our catalog from FITS. Okay, our catalog, and convert into plain text format. So catalog.txt. Okay, so now we have converted. If we have a look at the current directory with ls, we can see that we have the original raw catalog and our plain text catalog. Let's remove the original one with the ugly name, just to be clear. Okay, now let's have a look at the catalog. Okay, with the program cat, we can have a look at any file. So we can hold here catalog.txt, and as you can see, we have so many information, so many lines. So we would like to see at the very beginning of the file, just to check some metadata. And to do that, we can use the program head. So we type in the command line head, and then data. Okay, txt. And then by default, this program, the program head, will show only the first 10 lines. Okay, if we want to have a look at the 20 lines, we can specify here -20, and it will show you more lines, okay, 20 lines. If we go one step beyond, we can have a look at the first, for example, 98 lines, and we will see that the header, so the metadata of this catalog, ends in this line, and then we start having the actual data, okay? If we want to do exactly the same, but for example, having a look from the bottom of the file, we can use the program tail, okay? Head, here we got tail, and then the catalog, txt. Then it will show you the last 10 lines from the end, okay? If we only want to see the last line, we can put here -1, and it will show you only the last line, okay? This is really useful when we want to have a look at the beginning of the file, when we are adding more and more information in a particular file, okay? So let's go now with the redirection. So for example, imagine we want to print in the command line ABC, okay? We have to use the program echo, and that will print into the command line the string ABC. If we want to keep the result in a particular file, for example, this file demo-. file txt, we have to use the operator rather than to redirect the output of this into the file that we want. Okay. By doing this, we have created this file. We can see with ls that we have created this file, and with cat again we can have a look. Okay. Demo, and we see that we have put the string ABC into this file. Okay. So let's move now to another interesting program, which is set. Set is stand for Stream Editor, and it is useful for editing the files. Okay, so for modifying the content of the different files. In this particular case, let's start, for example, modifying the last file we have created. For example, if we say set, imagine that we want to remove the letter B and change for the letter capital V, so it's big V, okay? So we put here quotes, and then we say we want to substitute, and then we put here 3 slashes, and in the first one we put the word, so the string that we want to replace, in this case B, and here we will put, for example, capital B, okay? And finally, we specify the file, which is demo.file, and we can see that it has replaced the small v with the big V, okay, here. And it has put the output into the command line. So let's use this program to change some values from our catalog. As you can see here in the catalog, we have some values that are -99, which is really strange, and that means that they were not properly measured. Okay, so for example, we also have in some places 99. Okay, for example here. So we can set in the same way to replace all of this number by, for example, none. So we can set here replace or substitute any 99 with the value none. Okay, and finally we will put here the flag G, which is for substituting all the occurrences of 99, not only the first one in the catalog. Okay? Finally, we put here catalog raw txt, and as you can see here, we have replaced each 99 by the character none, which is not a number. Okay. If we now want to do exactly the same, but also adding, for example, the -99, which is a wrong value, here we have to specify the option -e and put something similar. Okay, -e, quotes, and then we want to substitute 3 dashes. Here -99 with the character space none and go. Okay, and that will replace all 99 and also -99. If we want to keep the result into another catalog, we can put it, for example, in another file, data.txt. Okay, I missed the redirection here, so we have to redirect here. So the content will be saved in this file. Okay, so we have a look now at the catalog. txt, we can see that we don't have any 99. So all of them has been converted into, has been changed to none values. Okay, now we know how to modify the content of our files. Now let's move to another program, which is grep, which is useful, for example, for extracting some useful data. Okay, so as we saw before, the original catalog has 2 different parts. The first one is the header, for which all of the lines start with a hashtag. So we want to extract all of these lines, and to do that, we are going to use grep. Okay, so we say grep, and then the criteria in between quotes. And we say, we want to extract all lines starting with hashtag. So all lines starting with hashtag from our catalog, which is catalog.txt. Okay, and it will put the output into the command line. Okay, you can see that all lines starting with hashtag has been put here, and we want to redirect to another file, which we are going to call, for example, header.txt. Okay, so if we have a look at this file, we will see that we have the header, so the metadata has been saved here. Now let's do exactly the same, but for extracting the data itself, not the metadata. So we can use grep again. Okay, so we can say grep, then the criteria. So all lines starting with hashtag from the catalog that we have. But we want the line not starting with this criteria. So we have to add here minus fit, which stand for inverse the criteria. Okay, now that will give to us all the data and not the line starting with hashtag. If we want to keep this into another file, sorry, we have to put here, for example, data txt. All right, so now we have the two different parts of the catalog, the metadata, so here in the header, and then the data itself in the data.txt. Now let's have a look at the header just to check what columns of the catalog do we want to extract. Okay, so again with grep, we can specify the keyword that we want to extract from the header. Okay, so for example, imagine that we would like to check which line have the keyword spec set, which stands for spectroscopic redshift. Okay, so we want to check which lines have this keyword in our header. And that will say, okay, this keyword is in these two lines. To be more explicit, we can add here -- color, okay, and you will see that the keyword is in these two lines. To avoid the difference between the capital letters and small letters, we can add here the option -I. So now we can say spec set in capital in small letter, and then it will look for any kind of letter, okay, capital or small letter. Now, if we want to, for example, look for two different keywords, we have to enclose them in between quotes. So we will add here. So we want to look for spec, and then imagine that we want to look for another keyword. For example, the filter F435, for example. So we have to add here a \, then a pipe, and another keyword, F435W. And that will look for this keyword into our header and also for this keyword, okay? And it will show you the lines that follow the criteria. So now that we know which columns do we want to extract, we can use another nice program, which is okay for selecting the columns that we want. So we say OK, and then write quotes. And at first, we want to avoid the line starting with hashtag. Okay, so we could use the data, so the file name data, which doesn't have any hashtag inside. But just to see how to use awk for rejecting them, we can say here, okay, we can we want all lines not starting with this criteria, starting with hashtag. Okay, and then in curly braces we have to say print, and then the columns that we want. Column number 1, which is an ID for each object. Then column number 94, which is the spectroscopic redshift, and then the magnitudes, for example, column number 10, column number 11, column number 12. And then let's do here another column, which is a color. Okay, so we are going to subtract the column number 12 from the column number 10. Okay, so this is a color. If we press well, before this, let's specify our catalog. So the original one, catalog.txt, and that will print in the command line the columns that we have specified. Okay, so the ID, the spectroscopic redshift, the 3 magnitudes, and then the color. Okay. If we want to put this output into another file, just redirect into a file name, for example, magnitude.txt, and that will be saved. Okay. Now imagine, for example, that we want to select only the reddest objects, so we can add another selection criteria using auth from this last file that we have created. So here we can put quotes and we say, give me all objects, all lines that for which the color is redder than 3. Okay, so the 6th column is the color that we have defined here. So if we do this using the catalog magnitudes, it will print only the objects redder than 3. Okay, as you can see here in the last column, all of them have values above 3. Right. If we now consider only objects that have a good value for the redshift, we can add another condition here. Here we want the reddest object, and also we want the object that have a redshift different from none. No? So we can add here another condition, so and then we want object for which the second column are different, okay, from none. And we have to enclose none in between double quotation because this is a string. And then the catalog is much smaller because we have restricted all the object to be reddest, and then also with a good value of the redshift. If we want to keep this in another catalog, just redirect into another file, for example, reddest with set, for example, txt. And now let's have a look. Catalog, so reddest. We can see that we have our subcatalog with criteria that we have defined. Now let's start playing with the data itself. So for example, let's consider that we would like to extract how many objects do we have in this catalog. So how many objects do we have here for which the color is redder than 3 and with a good value of the redshift. So to do that, we can use the program WC, which stands for word count, and we can just specify here the catalog, okay? Reddest. And it will say to you, okay, this file has 12 lines, 72 words, 601 characters. Okay, so immediately we are able to see how many lines. In this case, you can even count, no, by eye. But when you have a big catalog, you cannot do it easily. So if you only are interested in the number of lines, you can add here minus, so dash L, just to see the number of lines. In the same way, you can use dash W with the number of words, and the number of characters with dash C. Okay. Just to check that with the previous catalog, we have so much information, then with this one, we can say WC, for example, magnitude. Okay? And we will see that we have much more objects, words, and of course, characters in this other catalog. Okay? If we want to do this, but using the inverse redirection, we can do the following. So we have to put here the program, WC, and then the inverse redirection, which is done with this character, less than, and then here we put the file, okay? Rest with set.txt. So basically, with the redirection, we are putting, we are writing data into the files, and with this, with the other one, with the inverse redirection, we are reading from the file, okay? So here it is a bit stupid, but later Mohammad will show that it is really useful when, for example, considering while loops and so on. So now let's go with another really interesting and powerful tool, which is the pipes, okay? So the pipes are useful for considering the output of one program just to be used into another program, okay? So for example, another stupid example, imagine that we want to print hello IAC. So we will do the following, echo, and then hello IAC, and that will print this. If we notice that this is not good, but we want to replace hello with the first word with capital H, we can redirect this output into set, which is the other program that we have already seen, to replace the word H by capital H. So substitute, again, the letter H, the letter capital H, okay? And that's it. So we have used the output of this program to be used in this, okay? Now we have replaced hello with small h by hello with capital H. Again, you can use it in many other scenarios. No? For example, if we want to count the number of lines of one particular file, we can cut to have a look at the catalog. Okay, and we can redirect this, so we can pipe this result into WC dash L, for example, to see the number of lines. So immediately you know the number of objects that you have in your catalog. Of course, for example, if you want to have a look at the current directory, for example, with find dot, it's going to show you all the files that we have here. So we can redirect this output into rep with the option color, just to see which one of these files have the keyword, for example, res. And we will see that this file has the keyword res in its name. Okay. Another useful pipe, for example, is to use the program PS, which is for showing all the processes that are running in our computer. So this is all the processes that I have opened. And then if we pipe this into rep, for example, to see if I have Firefox open, it will show us that I have Firefox in this process, okay, with this ID. So about the pipes, it is something that almost all the programs in the Unix context also we use, but not all of them, just to be aware of this. So there are only a few that it's a bit complicated to use the pipes with them. Okay, so let's move again with our catalog. Now imagine, for example, that we would like to extract the object which has the lowest and the highest value of redshift. So to do that, we could sort our catalog, and to do that, we are going to use the program sort, okay, which is for sorting files. Then we will specify the column that we want to consider for the sorting, so dash E2, because our catalog has the redshift in the second column, and then our catalog. Okay, if we have a look before this, our catalog, we can see that it is not sort, but if we sort with this program using the second column, it has been modified. Okay, so now the first column, so the first object has 0 value for the redshift, and then the last one has the highest value. So imagine, for example, that, another important point here, sort is for sorting in general, okay? So it's going to consider also alphabetic sorting. If we are considering number here, it is a good option to say, to specify this option, that's n, which is going to consider this column as numbers, right? Just to avoid problems later. Okay, if now we want to extract, for example, the object with the lowest value of the redshift, which is this one, we can pipe this this catalog, which has been sorted, into head, which is the previous program that we have saved for having a look at the beginning of the file. So we will say sort using the second column minus n to consider number, then the catalog, and then we will pipe this into head, okay, just to see, for example, the first line, and that will give to us the object with the lowest value of the redshift. We can do exactly the same, but considering the object with the highest value of the redshift using the other program that we have saved, which is tail. So that will show as the last object in our sort catalog, okay? If we now are interested in the value of the redshift, we can pipe the result of this into awk just to print the second column. So in total, we could do something like this: sort minus key to consider numbers of our catalog, then pipe into tail just to consider the last object, which has the highest value of the redshift, then pipe all of this into awk just to print the second column, which is this one. Okay, so if we put here print second column, it will give to us the redshift of this object. Okay, so this is well, if you see here, you can see here that we have a lot of numbers. So if I in awk a format to print three decimals. Okay, so we can add here in between double quotation. Okay, I cannot see this. Let me make a bit bigger the screen. Okay. And now let's put here the format, which is percentage, then 0.3 f, and then n. Okay, comma here. That will print only with 3 decimals. And so I don't know why.
Use the print f, just the tiny point.
Yeah. So yes, print f with format, exactly. And now it's gonna print only with 3 decimals. Okay. So basically, this is all that I wanted to show. And now Mohammad is gonna show more complicated things, but this is the basic tool. So I will pass the control to Mohammad. Let's see what's gonna explain us.
Thank
so
you.
I will stop sharing.
Thank you.
Good.
Okay, thank you so much. Now we can, now I'll just activate my share screen and, okay, so I hope my desktop is visible now. Um, Okay, so well, Raul and I have already organized based on the files. So you already see all the files that Raul has made in the previous steps are already here, and we'll just continue following the really nice points that Raul made. So we'll start with variables because, well, shell is much more than just running one command and then getting the output and going away, right? It's so powerful. You can do many things with it. And to start generalizing your process, that's where we define variables. And okay, so we'll start with some basics. So remember, echo, just for example, 2 will print 2 for us, as we saw before. Now, if we do a equals 2 instead, it's not going to print anything. It's going to put the value of 2 in a. So when I do echo, and now the value of 2 is in a. So a is 2. So to get the value, to expand the variable from to read the value inside the variable, we put a $sign before it. So you see, $a will print, so echo will now see 2 instead of $a. And this allows us to generalize things, to expand things. And it's not just limited to numbers. In the shell, everything is a string. It's not, interpreted as like 2 being different from, for example, we can say A is the Redis catalog that Raul just made, right? So now when I do echo $a, you see, this time it's this. So it doesn't interpret the string. It just sees like, I don't know, any number of characters after the equal sign, and it will take that value, that string of characters as the value of the variable. So then the good thing is that once you start to define it like this, you can actually follow on the commands. For example, remember the cat command that Raul was showing the contents of the table with? Now instead of Redis with C, we can say cat $a, and it's exactly the same thing. And now you can already see how we're starting to abstractify, we're starting to generalize. So like if you have 50 catalogs and you want to select the reddest objects and like with the spectroscopic redshift, you just, in a loop, you just change the values of A, and boom, you have all of the whole catalog, like all 50 catalogs, you've been able to select your targets with it. Okay, and shell even allows simple arithmetic. So for example, let's say A is 1, and then let's say B is 2. And then we say, okay, well, let's have a look. You can also print variables together. So you can say $A, $B, and you can see you print 1 and 2. And you can even be really nice about it and say, okay, A is $A, and then like B is $B. You see, it actually puts the string of characters in the overall string that you wanted. So this is very useful. Like for example, if you want to use $A as a file name, you can just put a.txt. Look, it actually puts the 1.txt. It just sticks at the .txt after the variable a. Okay. And the shell allows you to generalize things. So you can even do arithmetic. So for example, we can say C equals to, so to do arithmetic, you have to do 2 parentheses, and then you say A plus B. So now look again, it doesn't print anything for C because the value has been written. So when we want to check the value, it's in memory. When we want to check the value, we do echo C, and there you go. You see the 3. So you can actually do integer arithmetic with this. It doesn't do the raw shell, the raw bash doesn't do floating point arithmetic. So yeah, if the values are a floating point, you're going to have problems with this. Okay, now in the next step, we'll see how I can deal with floating points. So like one thing as a scientist that like we have to deal a lot with is random numbers, right? And the shell even allows you to create random numbers really nicely, especially bash. Now this is a special feature of bash that I'm going to introduce now. So there's a special variable in the shell in bash called random, right? All capital. Look, every time you run it, it's going to print a different random number. And the range of numbers is effectively the integer, the range for 4-byte integers, which is with a sign. So it's from 0 to 32,767, which is actually 2 to the power of 15, take 1. So you can actually see every time I run it, I get a different number. And well, this is great because you can actually start to make mock catalogs, for example, or change a parameter and test your science while you're doing with it. And say, for example, this range of like 32,000 isn't really comfortable for you. You can actually do an integer arithmetic. You can say random, and then you can get the remainder with 100 or the modulo with 100. Now you see it's always between 0 and 100. It's really convenient. If you like another number, if you want like 1,000, again, you see it's all up to you. So again, you can use this random number to for example, make a file name. Like you want to make a random galaxy ID, you can say galaxy this, and there you go. You have a file name. You can start doing a fake study with it, or to test your science cases with it or something. Now, this is only integer, right? So if you want a random number, for example, as a floating point, and that's where awk comes in. So what awk is like, the symbol of elegance, I would say. It's like the most simple program to do such complicated things sometimes, in the most beautiful way. So for example, let's have a look. So we just pipe an empty string. You see, which I just wrote echo. I didn't pipe anything. And then, okay, I say awk. And then just like Raul did before, echo print. Before we would just like print the column. So like before we would say echo ABC, for example, and we would do like $1. You see, just printed the first one. If we put $2, it printed the second one. And like if we wanted the second and third one, for example, we would print them. Okay, but now instead of doing this, if we want a floating point random number, we just say, we just call the rand function. And there you go. It actually gives us a beautiful floating point number. But you might see something interesting. It's not changing. So the reason is that with awk, well, because it wants to be professional, right? So as a professional program, it has to be reproducible. It's so the seed, the generator for the random number of awk is actually fixed. So to change it, you can actually do what we're doing now. You can say echo $random, right? What we had before. So the good thing with random is that it changes every time, right? So we say echo random, and then in awk we say, so to tell it to change the seed of the random number generator in at the start of awk, we call that with begin. We say srand, and we add the first string that we have. And when we call random, you see now it actually okay, so I guess I have to call it another way, because yeah, now the value changed, okay, yeah, you see, so this number is changing. Okay, so I'll have to call it another way. So we do it with begin and srand, and here we actually call the random number variable, yes, then we just print, so to start the operation, we print, yeah, we just print rand. So one moment, yeah, this extra here. Okay, now you see, now it's working. Sorry, with echo, it doesn't work. Yeah, you see, now you have a floating point random number. And now say, for example, you can, with awk, again, you can mix this in with your like existing catalog. So you can actually, when you do the, when you run the awk, remember how Raul was running it before? We say reddest with Z. And over here, I can say like print $0. $0 means the full line. Okay, look, and now every time I run this, the last column is going to be different, you see? And I'm in control of the random number generator seed. So when you want to like make fake galaxies and do your studies, test your analysis, you can easily generate this random, and it's guaranteed to be equally distributed between 0 and 1. So it's a really convenient thing. And just to continue on Raul's point, another really nice thing, so like if you know, with awk is that you can also not have the full set of columns. You can even mix it, your random column with the other column. So look over here, I'm actually mixing it, putting it the random number column in the middle of the other two. And yeah, and just like Raul showed before, you can actually put a formatting. So printf is short for formatted print. So we can say like the first column is minus, we can give it -8 characters as an integer. And then we say, okay, minus like the next one is the random number and we only need 3 decimals. So for example, we say 0.3 and like, and we want a width of like, for example, 10 as a floating point. And then we want the last column again, like Raul showed, this is all junk, essentially all of the extra characters, the digits for the redshift. No redshift calculation can go to this precision. This is just floating point error. So we say, for example, 0.3 f for the redshift column. And okay, now you see you have to put a \n to have them on different lines. So now you see you actually have them in a nice, beautiful formatted table in plain text that all the columns are under each other. And it's a really good feature that you can use. Okay, so this was about random. Now let's go on to conditionals, because bash is not just limited to, you know, what, you know, a constant set of things. You can actually add conditionals that if something is true, do this. If it's false, then do that. And that starts to get to the power of bash. So again, let's define the, okay, let's set a fixed value for the, so let's read random once. And okay, now if we do echo x, you can see that we have the random number and now it's a fixed number. So then we say, okay, we want to check if, and this is how we write conditionals, if $x is greater than, let's say, the half point of, you know, that 32,000, for example, just, you know, rounded to 16,000. If $x is greater than 16,000, then echo like top half, for example, right? And then if else, echo, so it's going to print. So this part here is actually the commands to run. Now I'm using a really like absurd or simplistic scenario here, but you can make it as complicated as you like, add thousands of lines of scripting in the middle, and then you can say like bottom half. And yeah, you can even say like, in this case, I'm sad, this is like, yeah, it's low. And then phi is the end of if. So you see, if it's the opposite, that, you know, if and phi, it means start if and end if. And you see, it says, yeah, this number, because it was 32,000, right? It's 33,000. So it was the bottom half, and for example, we're sad here. Okay, but now you can actually, with bash, you can actually put multiple commands in one line. So we can put the x is random, for example, on the same line, and just put a semicolon after the first command. So with this, you can actually put like 15 commands after each other on the same line. You don't have to press enter every time. So when you do this, now so x is going to change in the same command. So look, as I change x, so why is it not changing? Let's have a look. Echo, I'm adding a new element to the random, to the string. And okay, you see, okay, now it changed. Yeah, so I guess it was, yeah, bad luck. For 3 times, all 3 of them were below the region. So yeah, you see, now it's changing. And depending on what, yeah, so you see, you can add conditionals, and you can also add conditionals like if a file exists or so on. Okay, now we can actually go start looking at, you know, now this is, for example, just a random number, right? You rarely want to like deal with a random number like this in this scenario. So let's actually go and read our catalog and do something based on the values of the columns in that catalog. So the catalog that Raul already made. So we'll do a cat like you saw before, and we'll have a look at the magnitudes catalog that Raul made, and we'll pipe it into while, right? While is another loop structure in bash. So then you say while and read. So read means, as the name says, you know, it's all simple English. So yeah, read this line, and with R, you're just setting it to the different variables, and you say, okay, read the first element as the first token as the ID, the second token as Z, and the rest of the line, we don't care for now. Rest of line, just put everything in the rest of the line as this variable rest of line. And okay, then do and done, right? This is the pattern for while. And then, yeah, we can say, okay, do, what do you want to do? Echo, for example, we say object $ID. For example, we just want to print a simple sentence, is at redshift $Z. Look, it actually went through all the 9,000 objects that Raul showed before, and it actually printed this sentence for us. Again, I'm just using this as a really simplistic case. You can like make mock simulations based on these, based on the commands that you give instead of echo. I just gave a really stupid demonstration example here. And this is, so like one simple thing that can start you off in your research is that, for example, you want to do some studies on this large sample of galaxies, right? So we'll just do an echo, for example, ID. You see, it just prints the ID for that column. But now, before that, so say, for example, you're doing your science, you're doing your studies on all of these galaxies, and you want to have a special file to keep the outputs for every galaxy. So let's make a directory and called sample, mkdir sample, and we'll write every ID into every ID and redshift, for example, of the object into sample, sample the directory sample. Remember the redirection that Raul was talking about? This is the same. So we're saying echo $ID and $Z, and then okay, so now we need a different name for each object, right? So we can actually say sample and then $ID.txt, right? So look over here, you see, we're just using the power of bash. So for every file, it's going to make a different ID. Look, it takes a while because it's 10,000 objects. So look, okay, 10,000 objects we just created. Let's have a look. If I do an ls here, yes, you see the sample file. And if I go and look inside the sample directory, look, it just done all of this in like in a fraction of a second. You saw yourself for like the 9,000 objects that we had. And if we can just like have a look at any random number, any random one of them, for example, cat paste, and also I have to put it in the random, so it's in the sample directory. Here we go. For like this object was like object, well, as we already know from the thing and from the name, and like it didn't have a spectroscopy redshift. So then, for example, in my science, now I can continue, like I measure the stellar mass of the object, I put it in this line for this object, for the other line, I put it as another line. And then, I continue my analysis on all of these like 10,000 objects really easily like this. Now, this simple scenario can be done, as I mentioned, awk is like the symbol of elegance, right? So you can do the same thing in a much simpler way with awk. You can just say awk, and then you say, okay, print from the magnitudes table. So again, you don't want the columns starting with a hashtag, and then you say, okay, print $1, $2, which is just like before. So we'll just put magnitudes here. So this is just like before. We already done this. But in awk, you can actually pipe, redirect the output in awk. So you say, you have to put it in double quotation. So it's actually interpreted as a string. And yeah, sample, and then you put $1, for example, which is the ID of the object. And again, you put double quotation and you put .txt. So before running this, I'll do an RM of the sample directory. I'll delete all of those files that I made a moment ago. And that's as simple as this. And you see, I'm doing it in the same command. And you'll often find yourself doing this a lot. You run the command like me now, and then suddenly you remember you should have done something simple before it. So you just do this. Okay, deleted that sample. And now awk made a new a set of contents in the sample directory. So if I do ls sample, there you go, I have this. And you see this awk command is much more simpler than the while command that we saw before. But the while command, okay, where is it? Yes, here, this was the while command. It's much more simpler than the awk command, but the while is much more general. And you can do much more interesting, cases and mix, instead of the simple echo, you can like put your SED fitting code here, and or I don't know, whatever science you're running for each one of these galaxies. Okay, now this was, based on an existing catalog and how you can parse the lines and read the column values. So then if you want an ordered set of operations, for example, so then you say, then the shell has this really super cool, simple command. It's called sequence or SEQ. And then you put, for example, 10, and it will actually print 10 numbers for you. I guess you can see where I'm going with this. I want to put this in a loop and like parse them one by one based on numbers this time. So with sec, you can say sec, and then, okay, if you just give it one number, it will be the maximum value. So now if I give it 15, it's going to be 15. If I give it 5, it's going to be up to 5, starting from 1 all the time. Now, if you give it 2 numbers, for example, if you say I want sec from 2 to 5, the first number is going to be the smallest, and the second number is going to be the largest. And if you give it 3 values, it's going to be the step in the middle. So look, now with now from 2 to 5, I have with a step of 0.5 or with a step of 0.1. So now you can actually see how we can put this in a loop and start looking at the objects. For example, there's another kind of loop in the shell called for. We say for I in, okay, we run the sec command. So this dollar parentheses and parentheses closed, this is actually, it says, run this command and put its value here, okay. So we say, for example, sec 5, and yeah, then do an echo of, for example, galaxy dollar I. This is very similar to Python. So effectively, Python stole this syntax from the shell. Because the shell is like 20 years older than Python. So yeah, okay, then for example, we say galaxy dollar I, and then done, for example. Here you see, you just print, for example, the galaxies in the special sequence that you like. And you can, again, like you can give it ranges. You can say 1 to 20, for example, and you run the 20 names. And now what we can do is actually we can go and have a look, for example, at the galaxies and that we already made in the sample directory. So we say do, for example, yeah, what we had before. So I'll just make this 1 and 20 again, and echo galaxy I. And then we can also do another command. We can say cat sample $i.txt, right? So look at the galaxy and see if you can find it. Okay, look, now you suddenly see, oh no, in the catalog, there was no object with an ID of 13. Yeah, well, this is a bad number for those, mystical people. But yeah, there was no object 11, there was no object 10, because the catalog has been, cleaned. Their original numbers, their original sequence of numbers were like, not, they were like cleaned afterwards. So like they removed these objects like 15 and 18 and 20. So, so you can put an if here. For example, you can say do, over here in the do, you say if the file exists. If you want to check for the existence of a file, you do a -f. And then you say, okay, if sample $i.txt exists, then do this, and then put a fee, before. Remember, the fee was the end of the if, and the done is the end of for. Now look, it only prints the galaxies that do exist. So like if I go in sequence from 1 to 20, I only have, for example, 5 galaxies. And yeah, then for example, I can make this to 50, and like seeing the first 50 integers, like the sample only had this many number of galaxies. So you see, you can actually mix the loops and the ifs and do really interesting things when it's necessary. Okay, so one of the last few set of commands, so we'll go over packaging. So you've done an analysis, right? And now you want to send your results to your colleagues, like you made a huge discovery, you found like a new population of galaxies, and yeah, you're really excited about it. Now you want to send it out to your colleagues. So let's have a look here, and let's assume that this catalog.txt now is your output product, right? So let's have a look at how big it is. So remember, I think, yeah, Carlos explained this in the last session. If you do catalog.txt with LH, H is for human readable, right? So it actually puts an M here. It actually shows that this file, catalog.txt, is 17 megabytes. Just for a check, if we do the raw.txt, yes, that's also 17 megabytes because we just changed the nans from 99, remember, in this step. So now let's compress this because you can't send, I mean, it's absurd to like send a 17 megabyte file. Plain text can be beautifully compressed, really nicely. So that's why that's where gzip comes in. Gzip is one of the most common standards to compress files. So you say gzip catalog.txt. And when I run this, okay, it does some processing because it's a big file. And if I do the ls minus lh, and so you see catalog.txt now has a .gz behind it. .gz means it's been gzipped, you know. If I do this, look, now it's only 4 megabytes. So now it's much easier for you to send or even for you to archive rather than having to keep this huge 17 megabyte file. It's the same thing in plain text can be compressed so nicely. So, you know, whenever you're sending around catalogs to people, don't send text, just do a gzip on it. And it's, and yeah, don't waste your email space or your computer space with .txt files. Okay, so now if you want to uncompress the file, so say for example, your colleague has sent it to you, now you want to uncompress it, you dogunzip. This is the inverse command. And then you say catalog.txt.gz, and okay, there you go. Now the .gz doesn't exist anymore. So that's the feature of gzip and all of these compression algorithms, because there's more. There's bz2, there's zip. Generally, they all have the same thing. So bz2 has bunzip and zip has unzip. You can use the same command, and they rewrite the file. So like they delete the original file and they, you know, they make the new compressed file. Okay, but gzip is only for a single file, right? Like this case, this only had a single text file, right? In many cases, you want more. You have many text files. So like say, for example, you want to send the results of all of these .txt files in this directory. So like ls_.txt, you see you have like all of these txt files. And say, for example, you want to send these to your colleagues. So gzip only does one file. Okay, so that's where tar comes in. Tar is the program to package files into one file. So let's have a look. If we do ls minus lh again, so you see, like you can see the size of each one of these files. Now let's use tar, and we'll tell tar to create a package. Then V for verbose, it will actually print the name of every file it adds to the package. And F means the name of the output. So we'll call this like my discovery, for example, and .tar. And then you say, okay, all of the .txt files. Now look, when you run this, because we asked for V, if we run this without a V, it's not going to print the file names. So this is V is just, you know, for visualization, you can think of it. It's verbose actually, but anyway. So now if I do an ls here, you see I have the, where was it? My discovery, here it is, my discovery.tar. But now this tar file is a package of all of those plain text files. So if I do ls minus lh star.txt, again, you can see the file, the size of the text files. And then if I do my discovery like tar, you see it's 51 megabytes. And this is, you see, it's the exact sum of all of these individual text files. So the size of the file hasn't changed. So now we can do gzip on it. Look, we run gzip my discovery.tar. And this will take some time. And if I do ls minus lh my discovery, now it has a tar.gz behind it. And you see the size of the file is now 14 megabytes instead of 51. And this is now much more easier for me to send around and work with my colleagues. Now say your colleague wants to unpack this. So let's make a stupid directory here, mkdir like unpack, and we'll go into the unpack to unpack the tarball. So we don't want it to populate, you know, rewrite over the existing ones. You see this directory is now empty. We do tar xf, you know, to unpack something. So C was to create, X is to unpack, and F, so tar xf, and then you give the name of the tarball. So unpacking is much more easier. You just say, okay, what was the name of the tarball, my discovery? And there you go. You see, I have all of my files that I received from my colleague here as plain text files. Okay, and close to the end. So now we'll have a look at, so as you saw today with Raul and me, we ran a lot of commands. So sometimes you want to see what you ran. So if you run history, it's actually going to print every command you've ran. Look, this is everything Raul and I ran. So like I can run reset. Reset actually cleans the terminal. And if I do history, this is essentially from the beginning of today. You see from the wget, and we ran all of these. We ran all of these. You can see them all here. And if you just, for example, want the last 10 lines, you can run history 10, or if you want the last 20 lines, so we can do a reset here. And to clean that thing. Okay, here you go. Now we have like the last 20 commands, and we can remember what we did, and put them in. And say, for example, you want a special command, so you can use grep, as Raul showed. So you can do history, and you do grep. Like, let's see what command was interesting. Let's say how many uses of awk we had. Okay, so you see, these are all the commands that we ran today with the awk command. And now you see in my computer, I've already set the color mode to default. So you can do that in your startup file for your terminal, for your bash. And you see, all the awk commands that I ran are here, and I can like remember them and write them down. So like to write them down, I don't even have to write them down. I just, as Raul showed, I just do this and I say my awk commands, for example, .txt. And when I do an ls, you see my awk command.txt is here, and I can actually, open this in the text editor, like for example, less my awk commands, and you see I can actually have all of my awk commands as a file. Now these numbers may be annoying, right? So now again, let's show. I guess you know what program I want to show. You can use awk, so we go to awk and we say, okay. Set the first column to empty, right? And then print the line, right? And there you go. Look, there's no more numbers because, before there was a number on every line, and the number is the first column. So again, with awk, now I can actually save this as a shell script, that annoying numbers, because, the numbers are good in some scenarios, but are bad in others. And you see how beautifully, how elegantly with awk, we were able to do the job. Okay, another way to read history is Control R. So when you're in shell, say I want to, I forgot my wget command at the start. I press Control and R. Look what happens. My terminal became reverse R shell, and I start typing wget. Look, it automatically autofills. This is the last time I ran wget. And if I run it, press Control R again, I see the last, even before that, and like just pressing Enter will automatically run the command for me. So this Control R is extremely useful. If you remember, like 5 hours ago, you ran a command in the same terminal, you remember the name of the program, but you don't remember exactly what you ran, and going into history is like too annoying. You can just use Control R. It's perfect for this. Like the last time I ran awk, you see it was here, and I can just press up and see all the other awk commands and press Enter on any one of them that I like. So this Control R is really cool too. Okay, now the final step, which I've been promising for some time, is the manual. So we ran a lot of commands, right? And I know you're already, maybe if you're just starting out, this is already overwhelming. There's too many things. And you'll think, okay, how the heck did this guy know, how to run awk? Where did he learn awk from, for example? So there's two sets of documentations on the command line that you can use. Man is the first one. If you just run man awk, it will take you, man is for manual page, right? Man page, it's called. You see, it actually prints, it's a one page, it's a one long page, like documentation that you actually have on your command line. You don't need to go to the internet, right? If you're offline, you don't need to go move your hand to a browser and take over and go to the touchpad or mouse and waste 5 seconds, navigating, or 1 minute navigating to some web page, searching something. You actually have it here. You actually have a man page. And if you want to search in a man page, you just press slash. You see down there, look at the bottom, I press slash, and I can search function, let's say. Look, it actually takes me to the next function, and I press N, and it takes me to the right point. You don't need the internet to remember things, right? These things are complicated, and the people that made them already knew they're complicated. And so they've done a really nice job at documenting these. So use these features. Don't go searching and finding the wrong answer sometimes and having to scratch your head for half an hour. After you run their proposed solution, you suddenly find out it's not what you wanted, for example. So man page is one format, and another format is info, which is more complete. Man page is a little technical. if you're just starting something, the man pages may be a little too technical for you and you may not be too comfortable. So that's where info comes in. With info OAK, if you press it, it actually takes you to the full book of OAK. So with info, for example, you see this is, it actually, you see it's the full book. It's like, you see, it's even like, it even has the copyright of this year. So it's like the most recent version. And you see, this is really complete. With the info pages, you have a very, very complete information, very complete book. And like, I can even navigate to the web page for you, for example, for GNU OAK. If I search GNU OAK, okay, we go to like the web page of OAK, and the manual for OAK is available here. And for example, in PDF, if I open it, you see it's like 570 pages. It's really complete. It's a whole book, really. But don't worry about the size. Like, only the first 100 pages are necessary for you. But you see this whole PDF, maybe the first time you're reading this PDF is a good format, because you see it's like you can just click on the column here, and PDF you can actually go on your mobile or tablet, or just even print it and read it nicely and learn. OAK's manual is perfect. I mean, the other thing that makes OAK really nice is that the GNU OAK manual is beautiful. It's for an absolute beginner. It actually describes everything from the start. Okay, but the thing I want to show you is that you have this whole 500-page PDF in your computer. If you do info OAK, and okay, so I'll come to the start of the book. You see like forward 3, forward 4, preface. If I come here, you see forward 3, forward 4, preface. It's the whole book. You have it on your command line in a searchable way without having to take your hands off the keys of the keyboard, not even the touchpad. Imagine how fast you'll get to do what you want. And info has a great the documentation for itself. So I really recommend, now I can't really talk too much about it, it's already over time, but I really recommend you to do info on your computer. And as the name says, it's a documentation for itself. And just spend like, it will only take you half an hour or so. But once you do this, for example, you'll be able to navigate to what you want really fast. For example, if I do info OAK again, and I want to see the functions, I just press S, functions, for example, and this will take me to all the occurrences of function. And with up, I can come, I'm pressing U now, I come up to the top of the table, and for example, I want to go to the functions chapter, for example. You see, this is a functions chapter, and over here you can see all the built-in functions. And here you go. It actually gives me all, you see, this is that random function that I was showing you before. You see, the documentation is here, and I didn't take my hand off the mouse or off the keyboard, off the typing pad, and with a Q, I just come back and I remember what I wanted. So don't worry, you don't have to memorize any of these things. If you read the info pages, it's usually enough. And another way you can get help is like just a simple help command, but that's really minimal. It's just if you know exactly what the option does, but you just forgot the exact typing or the name or something. Okay, I think that's enough for me. I've already gone 10 minutes overboard. So maybe I'll stop here and we can go to questions. Thank you very much for being patient with me, and Raul.
Okay, thanks very much, Raul, and thanks very much, Mohammad, for this very nice introduction to all of the portfolio that the BASH has to offer. We're over time. I think it's better if we skip the questions for today. We are, of course, all reachable by email. If you want to send the questions to any of the speakers or even to me, we'll leave it here for today, and we'll reconvene for the next seminar, which most likely will be at the end of this month, and it will be dedicated to the GNU Astro tools.
Yeah.
So
thank you.
Let's stop here. Thanks very much for coming, and see you around.